Hey everybody, this is a video on how to solve unfactorable polynomials. So unfactorable. I just want to go over really fast. In your previous math experience, you solved linear equations, that's power 1, and then you went off to the next class and you learned how to solve power 2 equations, which are the quadratics, right, with the u's. This class focuses on higher power solving. So we've been kind of building up to this. So we did these two at the beginning of the quarter, and now we're moving on to power even 5. And as you go higher up in degree, which is the highest power, you start seeing that not all of them are factorable. Okay, so what is the first thing you want to do? So go ahead and write this one down. We're going to solve it using the different tools that we've been learning. All right, so first I check to see, is there a GCF? So GCF, no. So what am I really doing? I'm going to try to factor this. So what would I go through? I would go through, is there a GCF? Is there a leading negative? And then last but not least, like how many terms does it have? So this one has 4 terms. So you know you're going to go through and try to, in your head, factor by grouping. And if you try the different combinations, it's not going to factor. So that's the point of the lesson. All right, so now that you know that it does not factor, what you're going to do is you're going to use the rational root theorem. And we're going to look for zeros, rational root. Okay, so what you do is you're looking for your P over Q. And in this case, the Q is 1. So this is actually the list we're about to make. The P over Q is going to give us all the possible roots to this problem or solutions. However, the list includes extraneous ones that aren't going to work. Okay, so what's the first thing you do? You're going to factor the P value. So that's the last number here. So this is 20, and you're going to factor it. So we're looking for all the factors, meaning what are the numbers that divide into 20. So I'm going to go by pairs here so I don't miss any, and then finally 5. Okay, so I have all those options, and then fortunately the Q is 1. So there's only one option for that. So then the next thing you're going to do is make that list. So what's the list of possible solutions? All right, so here's the list. It is, let's do this. It's all of the fractions that you're working with. So 1 over, well, actually, I'm going to list them out so you can see 2, 4, 5. Sometimes you don't get 1. Sometimes you're going to get some different numbers. So it looks redundant, but it's not. All right, so my only option for the Q is 1. Okay, and then the next thing you need to know is that it could be a plus or minus. And then you want to reduce the list. Okay, in this case, you're not going to see a big difference, right? So that's 1. Okay, so there is my possible list, and you can see it's ordered. And on tests and quizzes, it usually says order. Okay, I found all my possible roots. So now I want to show you that in my Google Classroom, so this is everybody's class, so even if it says a different period, at the very top of your Google Classroom, I posted a free online TI calculator. It's free for 90 days, and it only downloads on computers, so it's not going to work on a Chromebook. Hopefully you have a graphing calculator just to get the shortcut. There is a long way to do this, just so you're aware. I'm going to show you how to do that. It's based again on things you've done previously. So if you can download this because you don't have a graphing calculator, that'd be great. So you can see here I have my graphing calculator open, which is pretty cool, I think. And you have to click on the buttons. You can't just click on the screen, just so you're aware. So I'm going to go ahead and enter my equation that I'm working with right now so we can test the possible solutions. So as you can see, I inputted the equation, and now I'm going to go and start checking that list of possible solutions. So what I'm going to do first is go to table set. So if you can see my cursor, I'm around the blue button at the top that says second. So I'm going to click second and then window, which is the table set. What you want to do is you want to go down to the independent variable, which in our case is x, and we want to put it on the word ask. And the reason why is so we have control over what x value we're putting into the calculator. And then you're going to hit enter, and so now it's selected. And now we're going to go to second, and you're going to go to graph, the graph button. The very top in blue, it is the table, and that's what we want. So this is pretty cool because, again, you can check these solutions very quickly. So one of the solutions on our list was -1. So I'm going to put that one in there. Oh, awesome. So we got this 0. So you can see the 0 in blue over here. That means that we found a solution that we can use to break down the polynomial. So you only need one to start with. I am going to put one positive one in there to show you when it doesn't work. So you can see when I plug in 1 into the function, I get positive 24. It's not 0, so it's not a 0. That's where the vocabulary comes in again, not 0. So I'm going to use that -1. Of course, you could go down the entire list to see if you get zeros. And that would actually work to solve this problem. However, this will not show you the complex roots. Okay, so that list does not show you any complex roots, and so that's why you have to be careful about what you're doing. Okay, so just don't go through the list, just so you know. All right, we're moving on. All right, so this is the third step. I'm going to erase this work over here of those possible, and we're going to work on the third step. So the third step is now check the possible roots. And I'm going to say in your calculator, or zeros in your calculator. So what are you trying to find? You're trying to find when you plug in P over Q into your calculator, do you get 0? Okay, so that's to remind you what you're looking for. So in our case, we did find one, which was awesome. It was actually the first one. So we found that f of -1 was 0. So that means the -1 is a solution. Awesome. So now we can do the next step, which is D. We're going to be working with synthetic division now. And it's already solved for, right? That's a solution, not a factor. So I can go ahead and put that out, and I'm going to work out that synthetic division. So you can see I performed the division for you already. And I better put 20 here so you can see where that's coming from. And I want to point out some key features as to what you're going to be analyzing. Okay, that last number is the remainder. And it has to be 0 because we showed in the calculator that f of -1 was equal to 0, which, just pointing out, these two zeros are the same exact 0. Rational root theorem, 0 theorem. All right, so just as a reminder, since we're going down power 1, right, we're going to reduce by power 1, we're now going to rewrite. So the next step, ooh, got to spell that right. We're going to rewrite the function. So rewrite the function in factored form. So I'm going to call it reduced form or factored form. All right, so this is, okay, remember, I'm reminding you, f of -1 is 0. Thus, the factor is x plus 1. Okay, that's coming directly from the given solution that we found in the rational root theorem. Okay, then you're going to write what we found from the synthetic division. So we started with power 3, which now we're going to go to power 2. And remember, there's a 1 out in the front. I'm not going to write it. And so hopefully you can see where that is coming from. All right, what are we doing next? Remember, what are we doing? We're solving. So the next step is you're going to try to factor again. So what are you going to try to factor? You're going to try to factor the second parentheses. So sometimes it works, and sometimes it doesn't. So I'm going to come over here and do my x deal again. And I'm going to quickly find that this does factor. So that's great. But if it didn't factor, you would have to use quadratic formula. So that's awesome. Okay, so you're going to try to factor, and then you're going to rewrite the function again. And that's why I said in reduced form or factored form. So we're going to go ahead and do that. I'm just copying down that green again from the solution we found earlier, and then I can finish factoring. Now, could you have punched these in a calculator? Yes, on this problem, but remember I stated before that this method does not always show you all of the complex roots. Okay, they do not show up on a calculator. So when you go to solve it now, you're going to substitute in 0 for the y value and just go ahead and solve. Hey, do I have to show the work on this part? Because it's so easy I can do it in my head. Yes. Okay, because remember, this is an easier type problem. Same process though for all the problems, even though you will sometimes get complex. So it's just good to get in the practice of what you're doing. So this is equal to 5. And then you have all your solutions. So that was your first problem you did. So the next problem we're going to do is an example of when the solutions are not going to all show up in the calculator. Okay.